Hello friends, welcome to the thrust of curiosity. In this video, we are going to see the laws of thermodynamics. There are basically 4 laws, but first of all, we will see first 3 laws. First law is telling us about the conservation of energy in case of thermodynamics. So this Q is heat energy or dQ is a change in heat or heat supplied to the system. So here what it says, if we supply the heat, then that heat will be converted into useful work done, or the remaining energy will change the internal energy. U is denoting the internal energy of the system. So therefore, what it says, there is no loss in energy here. So whatever supply, that will be used either to do the work or to change the internal energy. Here, when you solve some numericals, you should know what are the sign conventions. Sometimes what happens, in some books you might have seen W is equal to minus PdV, and in some books you have seen W is equal to plus PdV. So when to use plus, when to use minus? Because if you use plus and other times you use minus, then the calculation may be wrong. So if you are using this all sign convention by system, if the work is done by system or if the system is absorbing the energy, then we are using, if the system is provided some energy, then system will absorb energy, so that time dq is positive. In that case, dw or just w is considered as a negative minus pdv, and du, if the this is just simple as this, there will be no confusion with du, but just between dq and w. So if we are looking absorption of heat or release of heat by the system, then we must use, for absorption dq is positive, for release dq is negative, and we should use this minus pdv for this. But if we are using the sign convention using on the system case, so in that case, if we are providing the heat, dq absorbing, but that becomes negative, and in that case w is equal to plus pdv. Okay, so you should remember there is some distinguish between these two. So which sign convention we are using, that is important. So in our course we are using sign convention by system. So we are using W is equal to minus VdV, and if the system is absorbing the energy, Q will be positive. Okay, or in other words, positive energy is supplied to the system. Okay. Then this first law tells about the conservation of energy, that energy can convert in one form to other form, but it does not tell anything about the direction of heat flow. Therefore, in second law, it says that the direction of heat is from hot body to cold body, or higher temperature to lower temperature. Just like other cases, like water flows from high potential to low potential, or the charge, positive charge, flows from high electric potential to lower electric potential, or even water also flows in the same. It is in gravitational potential case. So this heat engine is a very basic example. Naturally, the hot body will release some energy and cold body will capture. In between, we are going to do some work. So we can consider this part, the hot body or the reservoir which gives you the energy, is called as a source, and the cold body which absorbs the energy is called as a sink. So while passing the heat from source to sink, we can do some work done, and again this law is obeyed there. So total energy dq is passed here, so dq is transferred from h, then out of that w is work done, and remaining that will be du, that will be changed, that will change the energy of the sink. But what we consider is these two are infinite reservoirs. Infinite reservoir means even if we are taking some heat from this reservoir, there is no change of the temperature of this. Similarly here, even if that sink is absorbing some energy, there is no net change in the temperature of this sink. This we can consider as our sink of the water. So if we start a tap, that is like a source of water, and whatever we are washing something, that we are doing work, and remaining water will go to the sink. Same case we are imagining here. So this is a natural flow. Now what happens? This says, second law says that reverse is not possible naturally, but whether it is possible artificially, the answer is yes. So we have invented the refrigerator using the same principle. What we do, you can see here the arrows are reversed. Okay, here the heat to high to low temperature region. Here the heat is flowing from low temperature region to high temperature region, or sink to source. How? Because we are supplying some work done, external work done we are supplying. Only then this is possible. So there are some alternative statements for second law. You might have heard Kelvin statement or Closure statement. There are so many statements are there. But what I am telling you, this theory is important, that you cannot pass the heat from cold reservoir to hot reservoir without use of any external agency or without use of any external work done. Just like we discussed about the water, here also we can discuss about the flow of water. You cannot naturally pass the water from low potential to high potential, or from trough to crust. So what we do, we apply electric motor to pump the water. So that is the same case, we can use it in the thermodynamics. So this is the second law. It says that the direction of heat flow is from hot to cold, or from higher temperature to lower temperature region. Reverse is not true naturally, but with the external supply we can reverse the direction of heat flow. Now the third law says, now this question is arised in the second law, if we can give infinite amount of work, can we attain the temperature equal to 0 Kelvin here? And that is given by, the answer is given by the third law, that 0 Kelvin cannot be attained. Okay, 0 Kelvin, not 0 degree Celsius. Okay, 0 Kelvin cannot be attained by any external work. Okay, so these are basic three laws. They have no proof. Okay, but we have the experience of all these things. So therefore, we most of them don't need also the proof for these laws, but we can use them because we have some experiences that we can see the energy is flowing from hot body to cold body, and we have developed, like refrigerator we have developed, and using all this thermodynamics. Then there is a last law, but despite of calling it fourth law, we call it as a zeroth law. This is because this is very fundamental law. So basically tells zeroth law. Suppose we have three different bodies, A, B and C. So basically what it tells us, if A and B are in thermal equilibrium, B and C are in the thermal equilibrium, then A and C must also be in the thermal equilibrium. So this zeroth law gives a idea of temperature. So this says that, okay, if the temperature of this two is same, then temperature of this two is also same. So therefore there will be no net flow from any of these bodies, not even between these, because all are at same temperature. So net change in temperature or net heat flow is equal to 0. Thank you for watching. Like, share and subscribe.